Hi folks, I'm Andrew Yoak from Otterbein University, and I'm going to be talking about StreetDogSim. This is a computer model that I have built in conjunction with Dr. Kellen Callinger and Dr. Ellie Hibby to help plan out street dog interventions to try and reduce the amount of uncertainty there is about starting up a new program or altering and editing programs that are already running. So let's talk about why we would use StreetDogSim and the use case for it. Right. Where do we start? If we were to go to a city like Jaipur in India, there's already a fertility control program. There's already a program that's been running for 25 years. We don't need to give advice to these sorts of programs. But what if help and suffering doesn't exist? What if this hadn't ever been done and there was a large population of dogs in Jaipur that was uncontrolled and unregulated? Well, if that was a new city or a new location that we're coming to, how would I know what I should be doing, right? I would go to another city of a similar size with similar systems and hope that they could provide some advice. But what if there isn't a city that's doing a really good job with a similar setup of dogs with similar human dynamics and dog dynamics and similar size, right? I would need some advice that's a little bit more tailored to my particular situation. When I'm doing this, I need to know when I should be seeing results, how long those results are going to last. What am I qualifying as a good job? What is success in this system? So one way that I could do that is I could go back and spend a bunch of money, spend a bunch of time and man hours, and do things and potentially waste a bunch of effort and money. Then I would just go in a time machine and go back to the beginning. If that's not an option that you have, then it's better to plan out these sorts of things ahead of time so that we're not wasting effort, time, money before this. Planning tools like what I'm talking about here are a great way for us to produce a guidance for this sort of system that's going to give us a good idea of if we do X, what are we expecting at the end of this? What is it we're expecting to see come out of this? We can try alternative strategies. We can say, hey, what if I spent a little bit more money here and a little bit less money there? How would that affect things? How would that change the outcomes? Then, when we bring these sorts of strategies to the real world, we're not wasting a bunch of time. We're probably still going to get things wrong. We're going to have to make tweaks and changes, but it's going to reduce the amount of waste that's inherent in this sort of structure system. StreetDogSim is a tool. It is a tool that we can use to plan these sorts of programs out ahead of time. It is open source. It is in a language called NetLogo, but you don't need to be able to do any sort of coding. There's no C or Python or R or anything that you have to be able to do. It's simple point and click and entering in your local parameters. The idea of this is to make it entirely customizable and entirely easy to use. That is the whole driving point for this. Dogs in one area of the world are not going to be the same as dogs in another area of the world. We can't provide generic advice for non-generic systems. So when we do this, I want to be able to have functionality and give you the ability to tailor these sorts of inputs to your particular localized environment. When we do this, we create a map, a background, a city for these dogs to be in. We can produce a generic map, and it's very easy to do that. NetLogo can do it over and over and over again for us, right? We can produce a lot of variation in this. You're seeing different colors in this map, which are going to be different dog densities, just to produce a little bit of randomness, a little bit of stochasticity in the model, so that we're not making predictions based on a particular arrangement of a city. We're actually allowing a little bit of heterogeneity, which is what the real world is all about. Or we could actually import a map of a location that we're working in, right? So for this case, I just took Lagos, Nigeria. So really simple photo editing. You don't have to have Photoshop or skills or anything like this. You can just create a silhouette of your cityscape and then import that into NetLogo. Then NetLogo is still going to be able to do that same sort of zoning to provide some heterogeneity in the system. So you can still create a system that looks and behaves like the sort of model that you're going to be interacting with, like the dogs that you're experiencing day to day. Then, once we have our map, we seed that map, we apply the dogs to that location, and those dogs, again, need to be tailored to a particular scenario, so those dogs need to have traits that are specific to your area. Things like survival, reproduction are not going to be the same. Dogs in Lagos are not the same as dogs in Concepcion, which are not the same as dogs in Miami, right? They are different systems, and we need to tailor the advice to a particular setup. So we can do this with just a simple slider. You can see it's a little slider that we can just go up and down to modify survival rates so that they match what you're actually seeing in your real world. We're also being allowed to do things like changing the rate of abandonment, if you have variations in the amount of licensing and registration of dogs in your area, then maybe you want to tweak it down, maybe you want to tweak it up, right, to match whatever your particular system is. Also, things like uncatchable dogs are not a great thing, but they're part of the real world. There's going to be dogs out there that we're never, ever going to lay hands on because of some behavioral thing, or they live on a dump or something like that, right? These are going to be dogs that are immune to any sort of interventions we would ever want to apply to them. Then, now we have our map. We have our dogs that live in our map. We let the population run. The dogs age, they die, they breed, they have their kids grow up, their kids breed, their kids die, right? They live their life, their little doggy lives in this computer simulation. And now what this has done is provided us a tremendous opportunity to produce this sort of like little petri dish for experimenting on. Now I can do things to this system that would cost me hundreds of thousands of dollars in the real world, and then I can just hit repeat and do it again and again and again and again, and then try something else, try a different strategy, tweak and modify things, change how you're doing it before I ever have to build any kind of veterinary system, before I have to hire specialized dog catchers, before I have to build vans, etc. I can tailor and get a better idea of what the kind of needs I would actually have depending on the kinds of outcomes that I'm hoping to see. So the interventions that we would be applying to this in the system that is already built in NetLogo right now, we already have things like lethal control and sterilization and vaccination schemes. We allow you to change how long your intervention is lasting, right? If you're only expecting a very short amount of funding, how is that going to make the population look? How is it going to change once that intervention stops, right? How many dogs are you catching? What is the size of the dog population in your city, right? All of this is tailored and completely customizable in just these little drag and drop little teal boxes, right? You literally just click on them and then change the numbers, and then it's going to produce a different model system. When this runs, now we've produced a very, very complicated equation, but we've reduced it to just putting these values in and letting it go. This is a really nice part about these sorts of agent-based systems, that it's much, much more complicated than just simply tweaking some dials to get the number that you would expect. But now we have the option of running these sorts of experiments and actually seeing in the real time how that's affecting things. For example, if I were to take this population model, I think there was 20,000 dogs in this system, right? If I catch 50 versus 500 dogs, how is that changing things over time? Right? And I could run this, and I could just run these two maps, but that would not be the best use of this sort of system. What we would actually want to do is we'd actually want to produce a system of replicates that are actually going to be able to produce more robust results, so that I'm not basing my entire project plan on one particular map. I want this to be a result that I've expected to see most of the time, right? I want to try and get close to reality. So you can see it produces an output, and then you can see how it's changing the dog population size, how it's changing vaccination schemes, or if this is a lethal control scheme, etc. Right? Whatever we're doing to this system. So when this model is produced, right, you've input all of your parameters into it, and at the end of it, it's going to take 10 to 15 seconds, give or take. If you're doing this over and over and over again for thousands of model runs, we're talking about 20 minutes, give or take, to run this model. It's not going to be something that you need to run on a supercomputer or anything ridiculous like that. When this happens, we're able to get the most important thing, right? The most important output that most people care about is going to be the dog population. But also, some underlying characteristics are already built in. How many surgeries do you have to do? How are you affecting the age distributions? How is it affecting vaccine coverage? That sort of thing, right? I'd like to hit a certain percentage to control rabies, or if I'm doing a distemper vaccine, etc. Right? So how it's affecting vaccination coverage. That is how you would go about using the model, but we've already done a substantial amount of running to try and produce some general guidance. And this is what's actually being written up, and it's going to be in a paper that's going to be published hopefully later this year, that's going to provide general systemic trends, right? Trying to say, hey, if you do X, you should expect to see something like this. So the sorts of experiments that we did to give you a better understanding of the sorts of ability for StreetDogSim to be flexible is we've done things by changing how much effort we're doing, things like captures per month, changing things like the quality of the vaccine that we're using. Are we using the cell culture, egg cell culture? We're using something like IMRAB3, right? Whatever vaccine that we're using. Are we changing and choosing between different kinds of interventions? Should I be doing females only, or should I be doing males and females? If I have somebody that's advocating for a lethal control scheme, right, what does that look like if we were to do that compared to something like a female-only CNVR or a vaccine scheme? As well as things like duration of the actual program. How long is it lasting? How long are we intervening for 5, 10, or 15 years? So we've already done these experiments, and we can give you a better understanding of the sorts of results that you should see. The intervention duration is going to be terribly not surprising, right? Longer is better, right? The longer you do something, the better you can suppress the population, and the longer it stays down after it's been suppressed. You see a pretty big dip here, but then you see a slow decline and then reclining back up to a population once you've halted the intervention for this CNVR, this fertility control. But notably, down here in the lethal schemes, you see more of a V-shaped curve than the U-shaped curve that you see above, where the only thing holding down the population number was this actual intervention. If we don't intervene, the population rebounds quite rapidly because we're just bouncing back up to carrying capacity. Vaccine duration, again, not too terribly surprising of results, but good to know and good to see that this is producing, this is matching what we would expect to see in the real world. The longer the duration of the vaccine, we get pretty substantial increase in vaccine coverage. Notably, the reason for this is if we're using low quality short-term protection in this vaccine, many of our dogs are actually going to be tipped. They look like they are vaccinated, but they're not actually protected against whatever pathogen, rabies, distemper, parvo, etc., that we're trying to protect them against. They're not actually protected anymore because they've outlived their protection. They've lost immunity by it waning over time. The other thing is the amount of effort that you're doing, right? Also, unsurprising, the more effort, the more of an effect, the more you're able to suppress a population. You can see that for a fertility control that's targeting only females in green and a lethal control program that's targeting males and females here in red, right? It's better to do more effort. That shouldn't be terribly surprising to anyone, but it's interesting to see that we actually do have a little bit more of a suppression when we're talking about a high effort lethal control compared to a similar high effort fertility control scheme. This makes it look like that lethal control is better, but I'd like you to hold on to this idea in your head for a second, because when we compare them at kind of middling intensities, there's actually a pretty stark trend that we want to see in age demographics. When we compare the apples to apples interventions, where we're doing the same amount of dogs per month, they're doing the same interventions and same selection criteria, female-only CNVR is best. We think that CNVR is best not only because it gives you can see these box plots are very wide. There tends to be a pretty big variation in the outcomes that we see with lethal control, whereas we're pretty much always down in this low range for female-only CNVR. We still get not that much reduction in the population size when we're doing things like vaccine only here in the blue, which is not terribly surprising because there isn't any disease in this model right now. We're just seeing this for vaccine coverage. So this is kind of like unaltered. This is what the population ends up looking like. Why are we saying that female CNVR is better? Well, when you look at this, it's not only looking at the number of dogs that are in the city, but what is the makeup of those dogs? We actually get a significant increase in overall age when we're doing fertility control programs. The number of dogs that are under 3 years or under 6 months old or puppies goes way down for our female-only CNVR. Where if we are doing a lethal program, we're actually pushing the puppy distribution up. We're actually having more puppies in the population. Why is that a problem? Well, more breeding, which is what you're happening when you're doing more lethal control, right? You're not actually pushing the population down long term. You're artificially kind of dragging it down, but still it has this capacity to buoy back up. More breeding means more puppies, means more females in heat, causing more fights. Those puppies and fighting are our indicators for when humans get bit, right? So by pushing this population puppy percentage up, that's actually increasing. We actually could be doing some harm to individuals, making people more likely to get bit in the system. Right? General trends that we're looking at, female-only CNVR is best, high intensity better than low intensity, and long is better than short. Not too terribly surprising in terms of outcomes, but it's good to see and good to see that this is matching what we would expect to see. But the problem is, or what the rub of this is where it actually interacts with the real world, where the rubber meets the road in this is you've tailored this to your particular system, your particular city, how many dogs and what program you want to use. Then you need to be able to adjust this and say, yes, 500 dogs would be better than 400, but 400 can still be really good. We can still do a really large amount of effort and it can still be a big benefit to a community, even if we're doing not the highest, not the max longest duration. We can still do a really good job in modifying these systems. So, any questions I have, I can answer them now. There is a full tutorial on how to use StreetDogSim, and the model is going to be available on ComSAS here pretty soon. They just got to approve it. And then the tutorial is at bit.ly/StreetDogSim. Send me an email if you have any questions or you want to have access to the model, and I'm happy to share. This is all open source and all free. The more people using it, the better for me. Thank you very much.